This is Dr. K. Rajendra Prasad. I am working as professor and head for the departments of CAC Data Science and also CAC Cyber Security. Today I am going to give the lecture on regular expression to null NFA. So we have to see that previously the class is presented regarding to regular expression to NFA only, simply NFA only. Because of NFA, we have the two options with null NFA and also without null NFA. So we have to discuss it earlier class regular expression to NFA only. So in today class we focus majorly on null NFA. Means any language is given, how the language that can be defined by one simple expression. That expression is called as a regular expression. After obtaining the regular expression and to convert into some kind of a null NFA. So null NFA, generally we can denote the expression is null nothing but this epsilon, a symbol. So this symbol indicate on some kind of transition that is called as null transition. So in the null transition, why? Because of suppose you want to go any state without reading any input symbol in NFA diagram. In that case, without reading any symbol, by default you are assuming this kind of symbol is called as a epsilon symbol. This epsilon it indicates what kind of transition nothing but null transition. So here we have discussed the conversion, the specific conversion we have to discuss from regular expression to null NFA. So that today the discussion of the topic is construction of null NFA to regular expression. So we have to see that in that the user expecting what is the input is. That is we have to discuss. The input is so in the finite automata the second tuple is sigma. What is sigma is it indicates the alphabetic pairs. Suppose for example I am taking the sigma is a comma b. So totally for how many strings, how many different strings you are going to validate is. The strings it may be for without reading symbol, generally means without reading you want to move from one state to another state. That corresponding NFA is called as null NFA. Or single symbol on possibilities means using A also sometimes you have to move from Q0 to Q1. Another symbol is B symbol. So B is I think it is also you are take some single transition. The transition level is B when you moving from Q0 to some Q1 state. At that time you take the B. Suppose I am taking the combination of the string is AB nothing but what you are applying is a concatenation operation. It is called as a concatenation operation. Means we have to see the scenario is Q0 to Q1. Suppose for example I am taking the Q0 to Q1 is A and Q1 to Q2 is suppose for example is B. So when ending with the final state starting from Q0, so totally hard reading what is symbol nothing but A. So means we have to generating totally for how many strings using the sigma nothing but 4 different strings. These are called as 4 different strings. So these 4 different strings that can be defined by some kind of language. This language it takes what are the value strings or what are the strings. Strings nothing but you are getting null, A, B and AB. But what are the value string? So value string nothing but which strings you are going to accepted by the for particular finite automata. This string is called as AB string only it becomes valid strings. What about A and B nothing but so when you reading the A symbol, I think Q0 is not a final state. Means A is not only single A is not accepted, only single B also not accepted. Then you have to accepting what the string is AB only. So you have to finally the language string is for this example is AB. Suppose you want to show the language strings are null value, A value, B and AB also. At that time, you want to modify the diagram is like this. So because of so you want to accept null symbol also. You want to accept the symbol is small a and also accepting the B and also AB symbols. So what the corresponding diagram is? So I will show the diagram is for example here I am taking the state is Q naught. I am taking the state is Q naught. So when you are going from Q naught to Q1, Q naught to Q1, okay. So then so you have to accept what string is A. So you should accept the string is A nothing but it must be final state. It must be final state. This final state defined by double circle. So another string is you have to go for reading the B. So B also only B is also accepted. That's why when you are coming from Q0 to another state Q2, okay, at that case B is also accepted. Means the previous diagram is accepted totally for the string is AB, not for the single symbol A, not for the single symbol B, and not for the null symbol. But you want to accept all these kinds of symbols, you should modify the diagram, find the automatic diagram like this. Almost string is AB. So it means A is followed by B. A is followed by B. When you know that the acceptance of string is AB string, totally you are getting the substring is AB. Only that case the string entirely AB is accepted. And one more is missing null symbol. What the null symbol? So without reading the symbol. Suppose you want to go for another state that is called as Q4. Okay, they also using the final state. We define the null. So finally, you have to see that when you're reaching one final state is QF, you accept the null. Okay. When you're reaching the final state Q1, you accept the A. When you're reaching the final state is Q3, you accept the string is AB. And when you're reaching the state is Q2, you accept the B. So means if modified the diagram is final diagram is like this, then is having what are the totally for how many valid strings are 4 different valid strings. Okay, for these 4 valid strings, that can be accepted by the single finite automatic is FA. So finally, we have to see what the language. Okay, here there is a language of what you call is regular expression. But what the regular expression is, you want to define the regular expression is regular expression values are here. Regular expression values are here. Null plus A plus nothing but R plus B plus AB plus AB. This is for the regular expression. This regular expression that can denote for what are the strings are there in particular language which is already accepted by the finite automata. So entirely, so we can represent the elements of the particular language or valid strings of the particular language that can be defined by the regular expression is R. So totally it is called as L of R. It is called as L of R. That is, I am saying what you are expecting. I think output is nothing but you can define the NFA. Okay, that NFA is accepting the what are the things are the strings, nothing but the valid strings of the language that can be defined by the some regular expression is R only, and for accepting the corresponding language is called as language. The equivalent language of the regular expression is R. This is called as L of R. So what the R is, you know clearly. Okay, from this sigma, okay, the R is nothing but it may be for null symbol or A or B or AB. This is called as a regular expression. For that regular expression, what the corresponding language is? Corresponding language L is having a set of value strings. In that set, what the elements are? The one value string is null value, another value string is A value, one is AB, one is B. So you have to determine or you want to find the corresponding null NFA diagram for accepting the corresponding language of which regular expression is R regular expression. That is, you are expecting the particular output. So this I think idea of input. What the input for this corresponding concept is, you want to expect the input is the regular expression. Then regular expression R is given. Then you can define the L of R. And after that, you have to find the What the diagram is a null NFA diagram. Null NFA diagram. So for that, we should follow some basic notations for null NFA regard to the some basic regular expression. What are the basic regular expression? I want to write here what are the basic regular expression. So here the basic regular expressions are totally for your assuming one is null means you want to go for one particular state without reading any input symbol. That's called as go for the null. Null nothing but you can represent in the diagram is epsilon symbol. Second is a single symbol. Not only for a, you take any transition, single transition. A single transition symbol is a value yourself. So one more is other than a, you take b or you take c, whatever that. So means the single element, the element is either null value or any other symbol. In that case, we are using the basis. So basis, as per the basis regular expression or basic regular expression, you find the basis diagrams. This is the corresponding diagram. So what the null equivalent diagram is? Because when the symbol is okay, you have to reading the symbol is null. So you want to stop at the final state F. Okay, at the time you read how many symbols are single symbol is called as a null symbol. And one more thing is so we have to go for the second basis diagram. This regarding to either symbols of A or B or C. But this case I am showing the symbol is how the symbol single symbol A is accepted. The symbol A is accepted when you reaching the final state is F. Okay, we have only for single transition is A only. So means what I am trying is you are taking the regular expression null for the corresponding diagram. For the corresponding NFA diagram is NFA diagram. Suppose I am taking Q0 is one state, Qt is another state. Simply Qt is the final state, Q0 is the starting state. You put null. You put null. Suppose some symbol is A. Symbol is A. So what that at the time the symbol is A. What the corresponding diagram is? It becomes the same number of states. Okay. So the final states also we are assuming Q2 only, and initial state is Q0. But the symbol is A is a chain. So means there is no difference actually. In the transition, the symbol is chain. It may be null is accepted. It is a transition symbol is A is accepted. These are the corresponding diagrams. But you should remember. So after reading that null, you must end. How can represent the end is with the final state. Qt is must be defined as the final state. So next we have to see these are two steps are the basic steps. Remaining cases we are assuming three cases. One case is okay. First two cases are completed. I am writing third case is in this slide. So you have taken the union. So earlier I said what do you mean of union is it is also called as a OR operator. It is also called as a OR operator, or it can be represented by the symbol is either place or slash. Okay, so means we can make use of any one of the symbol either place or slash symbols. So that case I am taking or the diagram is this kind of a diagram. So you have to see that the symbols are totally for I am taking how many number of symbols are 2 symbols. Not a symbols, these are regular expression. Okay, S is one regular expression and T is another regular expression. You want to find the operation is S union T is also equivalent to S plus T is also equivalent to S or T. So means also union nothing but you make the union of two regular expressions values. Okay, what are the symbols you are getting under S and T? You make union of those two different things. And S plus T is also meaning of union. S slash T is also meaning of union. So this is the equivalent regular expression of S slash T. Okay. Here is the idea of S. This is the idea of T. Here between that you go for this direction. Okay. You read S and you have to finish it. Okay. That's the R. One more direction. So you want to go this direction. You're reading the T. Okay, and end with the final state. So these are your assuming. Okay, this is the regular expression for S or T. Suppose I'm giving the example is the idea is A, one symbol is A, okay, another symbol is B. One is A, another symbol is B. So as per this syntax, I'm writing like this: A plus B. So what you take first is initially A, okay, it's A, and another is B. Taking the B and create that here null symbols are there, no? We attach two null symbols before starting the ARB. You attach null symbols, define a state, and one is you have to end with another state. This is the ending state. This is the steps. Okay. We also null state. So this is called as A plus B. This is called as A plus B, or it is also called as A slash B. A plus B, A slash B. The meanings are same. So means initially you take the iteration A or iteration B. So once at least these are state. Okay, here I am not defining the names of the states. You are assuming the Q0, Q1, Q2, Q3 like that. You define some states, but you must define where you started and where your ending is. Okay, this is the syntax of T. So more is also very interesting. R equal to S with T. What the meaning is? R equal to S with T, nothing but you are applying S is concatenated with T, but dot is not applied here, which is equal to S dot T. Means S is some regular expression. I write this regular expressions like this. This S is regular expression. Okay, and T is another regular expression. And defining like this, T is another regular expression, and between that I am attaching some null symbol. This is a syntax. Class is final state. It's a user state. So means here also I am following yes. Some null tension is there here. Here it is T. Totally these two S and T that can be measured. So we have because of S dot null nothing but it's a yes. Totally this value is S. Again S with T. S with T nothing but which is equal to ST. So this is the derivation regarding to the R equal to S with T. So this is I think idea of what operation you are performing is here concatenation. Okay, this is called as concatenation. This operation you applied between the regular expressions are called as S and T. Okay, finally you are getting the final regular expression is called as S is concatenated with T. Simply can define ST. Okay, ST also, right? So thus we have discussed the equivalent regular expression, the finite automata, or for better elaboration purpose, I am giving this kind of notation also. So more is I think the third is R equal to S with star. What is R equal to S star is which is equal to, the meaning is closure of S. What are closure of values? S values are, you take one null symbol, a single time S is repeated, and two times the same S is repeated, and three times the same S is repeated, like that, which is called as S star. So here also we have to observe the same thing. Okay. So first we want to know how null is accepted. We want to move directly from state I to ending with F. Okay, what symbol is accepted? Null is accepted. Is it right? I put the tick for these two cases now. Suppose I want to go for acceptance of yes. This totally called yes. Okay. So first is the null. So we want to go for this direction. This is also important. I to this state to this state. So finally you are treating how many symbols are. This case is null. Okay, first is a null. This is you are assuming with yes. Next you are assuming this also null. So null with yes. Null with any symbol. You are getting a yes only. Yes with any symbol. You are also getting a yes. So S is one single S is accepted. Okay. So what you take is 2S. Means S is repeated. It may be 2 times or 3 times. That's a meaning. So suppose you want to go for like this, okay, this is also okay, but not go for directly if. Now you make some repetition, okay. So with this repetition you are getting another second s also, like the two s are repeated, three s are repeated. So finally this expression is called as what kind of expression is a closure expression, okay. We define that some regular expression, closure of that regular expression. This is the corresponding NFA, null NFA diagram. So, for example, I want to take one more simple example is suppose I am taking the input to regular expression is A star only. Okay, I am taking what is the regular expression is A star. Suppose I am taking A star. That case, what is the null NFA? What about the null NFA diagram? Okay, this is a question. So you write here Q0 to Q1, okay, with null symbol. Q1 to Q2, you can say A symbol. Q2 to Q3, okay, with the null symbol. So here you want to go for directly null on transition. You make a repetition, which is equal to A star. So here, with these concepts, we understood, okay, what are the basis regular expression. We have the two cases, single symbol, it may be null symbol or any other symbol. In that case, what are the resulting NFA diagram? That is we have discussed. One more is other than basis, okay, we have to go for induction step. Okay, that case we have see the some operations that's called as one is union operator, this is also called as OR operator. The symbols you are using, plus symbol between the symbols or slash. Okay, that case, what is the corresponding null NFA diagram? There is also we have discussed. And one more thing is after that, second operation is concatenation operation union. Second is concatenate. Okay, second operation is concatenate. That can be defined by the dot operator without dot also. I am taking the symbols S and T. S is some symbol, T is another symbol. What the final regular expression is R equal to S and T. So what the corresponding null NFA diagram? I given the syntax of the concatenation operation also. One more is it is also most frequently occurred while solving the problem of finite automata. That's called as closure of a regular expression. Closure of a regular expression. So what the closure is that can be defined by star symbol. Okay, A apostrophe star. So what the regular expression is A star. In that case, what the strings you are generating is a null symbol. Singleton is repeated, two times repeated. So what the corresponding null NFA is also I given the idea for the closure of any regular expression for the corresponding null NFA diagram. So with this, we have to check out one final example in today's class is construct null NFA diagram for the following regular expression is A by B, A slash B, nothing but here we are applying the operator is a plus operator. A slash B, nothing but A or B, whole star A B B. So directly you cannot go for solving of this problem. First you can divide this regular expression into some atomic statements. So if you have any confusion regarding the division of this atomic regular expression, we should follow some kind of pass tree notation. Okay, this and give the pass tree notation. So initially we have to know that R1 is A value and R2 is B value. So R1 slash B nothing but A slash B. Okay. So finally, so what the R3 indicate? R3 indicate this called as R1 slash R2. So this means what the R1 value is here A slash B. So like that, I given the clarity for each and every symbol on each and every atomic regular expression in the final regular expression. Like that you can divide, then you are going to solve the problem. So for this, you may assume what the starting is R1 equal to A, next is R2 equal to B, next is R3 equal to R1 slash R2, R1 slash R2. So after that, again there is some parenthesis expression. Okay, so you can assume R4 equal to parenthesis of R3. Okay, then we are getting what the R3 is R1 by R2. What the R1 is A value, R2 is the B value. Finally, how to getting the expression is A by B whole star. Means here why I'm saying why I'm saying is because of we should solve the regular expression of A first or R1, and you can write a null NFA diagram for next is R2. So NFA diagram for next is R3, NFA diagram for R1. Means at a time you cannot attempt for solving the problem of regular expression to null NFA diagram. Okay, after making some simpler, I think atomic regular expressions. After making some simpler statements, then we have to find what the R1, R2, R3 like that. After that, we have to write. We should write individually, and you may expand the regular expression step by step. Finally, you are getting the final NFA diagram for the entire regular expression. So this is I want to show how I'm analyzing this. So first is only for R1. Okay, here this regular expression for which one is R1. Is it clear? R1 is showing the A, the regular expression of R1. Okay, this is the regular expression of R1 NFA. Okay, the R1 equivalent NFA, R1 equivalent to NFA. And next we have to check it. Second is I'm trying this NFA diagram. This NFA diagram. So means you want to give the NFA diagram for individual regular expressions. Okay, you cannot go for finding NFA for at a time in a single step for entire regular expression. You should solve. First you have to solve this R1 regular expression. This is over in previous slide. Now you have to go for R2. So what next is R3. Okay, R3 nothing but A slash B. Basically A slash B. So what the regular expression is? I want to show this for this entirely it represent for which regular expression is R3 because it becomes A slash B. After that R4 is also there. R4 it added some other symbols or parentheses. It added some symbols or parentheses. Okay. Okay. Suppose I'm taking parentheses are optional. Parentheses are optional. These are the optional. Or you want to add it. Or these are optional. You are assuming. Okay. Next, what is R4 is R5 nothing but R4 star. R4 star nothing but this is the expression of R4. This is the expression of R4. And star nothing but you may first adding one null symbol. Next, you have to add the single time of that symbol, either R or B. Next, two times of the symbol is A or B. For that, you may expand. So finally, this R5 regular expression, this is the R5 regular expression. Okay, this is R5 regular expression. The equivalent NFA diagram is this is the equivalent to NFA. So this NFA for which regular expression is the R5. Okay, and after that, again we have to getting the idea is here. R6 is only for a single element. Okay, so that's why again you write separately. Then you can add to R7. So how nothing but I have to show that next step. Okay, this totally for R7. This for R6. This for R6. Okay, up to this is R7. Here null symbol is there. This for the R6. Okay, it is the way for I think extending the NFA diagram based upon the divisions of already derived sub regular expressions are R1, R2, R3, R4, R5 like that. Okay, and finally that's I think in this way we should continue. Here remaining part is left over is R8B and R10B. Okay, that should you should extend yourself for idea purpose. Okay, just I had to left the remaining part of the NFA diagram. How can add R9 for existing of this entire regular expression. After that, you should add the R10 also for the obtained regular expression of RL. Okay, so this is left for you, and the remaining part you should complete. You are getting some idea. And after that, you have to see another question is construct null NFA for the regular expression. Okay, construct null NFA for regular expression. First, you find what the divisions are. Okay, first I am taking R1 equal to A, R2 equal to R1 star. Is it right? For your purpose, I am making some simpler divisions. Okay, at a time you cannot attempt the the NFA null NFA diagram for entire regular expression, you make some simpler divisions. R1 equal to A, R equal to R1 star, and R3 equal to B, R4 equal to R3 star. Okay. So finally R5 equal to, you can write R1 slash, sorry, R2 slash, okay, R5 equal to R2 slash, I'm correcting here. Okay. So this is A star slash B star. A star nothing but you can define it as, this called as R2, this called as R2, this called as and R4. So now I'm writing R5 equal to R2 slash R4, R2 slash R4. So after that, finally I make R5 equal to R6 equal to, I put the parentheses R2 and R4. Okay, so it becomes a star. So in this way, I will give the idea. Okay, remind for diagram part. Okay, do yourself. But before the diagram, this division is very important. That's why I make it. I made the division of separation of individual regular expressions. But you should solve the NFA diagram for R1 regular expression. NFA diagram, you can extend NFA diagram for R2, and you can write another regular expression, another NFA diagram for R3, and for R3 you can extend R3 star closure of R3, that is called as R4. With the help of R2 and R4, you combine the NFA, what you obtain the NFA diagram separately, you can combine with the R operator slash operator R2 and R4 as per the syntax. Finally, you can apply the closures R6 equal to R2 slash R4 stack. So this I think today we have discussed. With this, I think the regular expression is I think well-known area, because of it is very important. You cannot defining what are the different elements, what are different value strings are accepted by finite automata for denoting, for covering of all these value strings. We should use some kind of expression is called as regular expression. That is, we have discussed. Once you know the regular expression and what are the conversion is, how can you convert the regular expression to NFA? And today class we convert the regular expression to null NFA. In that case, what are the basis diagrams we should follow, and what are the other induction steps we should follow in the case of R operator, concatenation operator, and also close operator. With this, today we are going to close the class. Before that, I am attaching some references here. So this one of the textbook is referred for this class. This is the main reference I am taking. And with this, I am closing today's class regard to the regular expression to null NFA diagram. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.